Hello, everyone. Today is, I believe, day 29 of solving a leak code problem every day. Today we're going to be solving invert binary tree. So I've already solved this problem, but it's been a while, so let's try doing it again together. So given a root of the binary tree, invert the tree and return its root. So here we have 4, then 2, 7, 1, 3, 6, 9. As we can see in this array here, because this array represents the uh, the tree. But once we invert it, we're practically just swapping each left and right child. So the left child here, 2, becomes 7, and 7 becomes 2. Here we have, let's see, since we swap these children, we also swap their children. So we have 9 and 6, but in the original tree we had 6 and 9, and then same thing here, 3 and 1. And for a simplified example, if we have 2 as the root, we just swap 1 and 3, so it becomes 3 and 1. Cool. So let's see. The first thing we gotta do is we gotta somehow traverse through this tree, because for us to swap through these nodes, or for us to swap these nodes, we must have some type of reference to each sibling node. So I think the way that's gonna make the most sense to solve this problem is doing it recursively. So what we're gonna do is start from the top, but then go all the way to the bottom, and then we're gonna swap all these bottom nodes, and then go a level up and swap those nodes, and go level up and swap those nodes too. So to start, since we're doing this recursively, we need a base case, and that's going to be if the root is equal to none, because if the root is none, we don't want to keep going. We don't want to cause an infinite loop. I guess another one could be if root dot left, and or actually it wouldn't make sense doing it that way, because that's just going to introduce a lot of things you got to take into account. So let's just do it this way. If root is equal to none, then we just return none. And the reason why this is going to work is or why we're returning none is because the children of, like, you can't see it here, but the children of all these nodes are technically just null, so we just return null. Anyways, next we can say root dot, or we gotta create a temporary pointer first, because we're gonna be swapping these nodes. So we create a temporary pointer, and then we can say self dot inverse tree, and then we pass this root dot right, or we're gonna pass that root dot left, because since we're setting root dot right over here, we're changing the reference. So we want to create a temporary reference to what this root dot right is, so we don't lose that node. And then what we can do here is root dot left is equal to self dot inverse tree, and we're gonna pass in temp. Then at the end of all this, we just want to return the current node that we're at. So I mean, a general idea of how this is gonna work. Well, let's actually run this first of all. Oh, I wrote inverse, meant invert. Let's try running this again. Cool, submit. And it worked. So a general idea of how this works is, let's say we have this tree, for example. We have 2 at the root, and then 1 and 3. So we start at the root. Root is not none, so we skip that. We create a temporary pointer to this 3. And then we set root dot right to be self dot invert tree root dot left. So what we just did is this becomes the result of this function. So we go 1 down to root dot left, and now we process root dot left. So if root is equal to none, which is not, we create a temporary pointer to root dot right, which is just null. And then we set root dot right to be self dot invert tree root dot left. So we go down 1 to the left again, but that's just null. So we return null, and root dot right becomes null, and then root dot left is equal to self dot invert tree of this temporary pointer, which is root dot right, but we go down here and that's none too. So we just return null. So nothing changes down here. But now we've gone through all this, so now we can just return the root. So now root dot right for 2 becomes 1 since we just returned it. And then now we do root dot left is equal to self dot invert tree of the temporary pointer. The temporary pointer points to root dot right, so we go down here and we just set that, or we do the same thing again, sorry. Root is not currently none, so we create a temporary pointer, which just goes to none. And then root dot right becomes none, and then root dot left also becomes none, and then we return root dot right, which is a 3 over here, and that becomes root dot left. So that's how these get swapped, and at that point we're just done. So yeah, I hope that makes sense. Space complexity of this is going to be constant, but you also got to remember the fact that we're doing this recursively. So, I mean, this is going to put stress on the call stack, but time complexity of this is going to be linear. And the reason why it's linear is because we just process each node once. So yeah, that's my solution for the day.